Do the count up.
Yep.
All right, so what we're going to do here is we're going to talk about simplifying some expressions and then something that's very closely related to it. So the title of today's lesson is verifying trig identity. An identity actually is a type of an equation. Well, it is an equation where the left-hand side equals the right-hand side. If you remember earlier this week we talked about it was simplifying trig expressions, where you had something that was kind of complicated and then you simplified it and simplified it a little bit more and simplified it all the way to the as simplest as it could go, which is always a good idea. It's a good skill to practice, utilizing your knowledge of relationships and formulas and identities. But then what we did is over here on the right hand side, we gave a reason for this. The first one was always given, but we gave a reason for that and a reason for this. And if you're going to become a math major, get your college undergrad or master's or even your doctorate in mathematics, this is something that you absolutely will have to do. For the rest of us, you're going to have to give instructions at some point, probably many points, the rest of your life, and document what's going on from step to step, or give, sometimes we call over these here, we call them annotations. Sort of a newer term for this is the metadata, the metadata. Sort of like this is the behind the scenes talk, or these are the notes, or these are the comments, or something like that. In mathematical terminology, sometimes we call these the justifications. This is what allows you to go from here to here. Okay, and we want to make this somewhat formal with the everything lining up, and sometimes the line down the middle can be helpful. We definitely want these things to look pretty good. So today what we're going to start off is with an actual equation though, and it's going to be something complicated on one side and then something simple on the other side. So it might be something complicated like, I don't know, this would be an algebraic example, x squared, plus 3x squared minus 5x, or something like that. And we're going to simplify it, and we would say, and there's over here on the right hand side, there's actually going to be an equal sign today, okay? And it'll actually have something on the right hand side, like this one would be, okay, equals 4x squared minus 5x, okay? And what we're going to do though is, in all reality, it's going to be a lot more complicated than this. We're going to have to somehow show that this left-hand side equals the right-hand side. So the parallel to sort of real life, this is a situation where you're like, okay, I know this is the problem, and I know this is the answer. I know this is the solution. This is what maybe the models are giving me, or the computers spin out the answer here, or this is what, maybe my gut instinct or my preliminary thought, this is what I know the answer is. And the question is, how do you get from here to there logically, okay, mathematically? How can you prove that step by step by step? And it's going to involve some thinking skills, sort of, that honestly are much, much bigger than math, okay? Some of the thinking skills are like, okay, which side is more complicated? Okay, obviously this side is more complicated. This side is the simpler. I want to try to reduce the complicated to the simple, okay? So this is actually sort of our tips and tricks here. So one of the techniques, it's not necessarily going to work every single time, but a lot of times it does, is we're going to reduce the complex to the simple. Well, obviously if you reduce it, you can't reduce it to something more complex. But identify the complex side and focus in on that side. That's one of the techniques that we're going to do. Some of the just sort of mundane, a little bit more boring stuff is we're going to use our existing knowledge of our trig formulas and identities. So I'm going to summarize that to use the trig chart. Some of the other techniques, we may need to factor. We may need to multiply by the conjugate. did that in Algebra 2. More specifically, multiply by the binomial. I can't conjugate. What the heck is binomial conjugate? Well, that means if you have a plus bx, the numerical or the algebraic conjugate would be a minus bx. So if you have something in the denominator like, I don't know, 2 plus 3x squared, you could multiply this by 2 minus 3x squared and 2 minus 3x squared. But of course we're going to have sines and cosines in all of these. Which brings me to one of the other points here. This is something I did before, but reduce everything to sines and cosines. Reduce to sines and cosines. That's normally a pretty good technique for simplifying these problems. And then I think we might have one or two of these on next week's homework. Maybe it might be on this one. I can't remember. It's always hard to identify. The traditional way that we're going to have this is that you pick either the left-hand side and you say that equals this, and then you say, and then that equals this, and then that equals this, and then that equals this, which happens to be the right-hand side. That's the way that our problems are going to work. Okay, we're going to say the left-hand side equals this, and then we're going to just apply the same stuff that we did earlier this week. Simplify it, simplify it, simplify it, and therefore it equals the right-hand side. And over here on across the bar, we're going to continue to give our justifications. The other situation would be if the right-hand side was more complicated, you would say RHS equals blah, 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 which equals blah, 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 which equals blah, blah, which equals blah, blah. And you wouldn't necessarily need to write anything over on this side because it's obviously still the left-hand side. And then which equals the left-hand side. That's the other way. That sort of makes sense. And then this is another thinking technique, critical thinking technique. Sometimes, if you can't find a way to get all the way from over here to that side, or you can't get all the way from here to there, okay, what's an alternative way? Maybe meet in the middle. Yeah, meet in the middle. Okay, it's also good interpersonal technique when you're trying to resolve a problem. Okay, you'd be like, well, I got to get this person to come to my conclusion, and I'm not going to get them to, totally, I'm not going to go to them. They're not going to maybe we meet in the middle. It's sort of a good idea. So if that's the case, you might have something like left-hand side equals blah, 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 and you can simplify that down to a point, and then you can say the right-hand side equals this, and then at some point you'll be able to say, aha, that matches this. Therefore, and I'll do the 3 dots, that's the technical math term of what I'm saying therefore. The left-hand side equals the right-hand side. Okay, so that's very, very abstract. Let's actually do some examples here, shall we? So here's your first identity. Secant squared x minus tangent x times cotangent x equals tangent squared x. Probably one of the most...
Is that times cosine or cotangent?
Yep, times cotangent. I guess one thing my calculus students see, sometimes they have an answer in their calculus problem, which is this, okay? Secant squared minus tangent x, cotangent x, and then they look in the back of the book and they see this, and they're like, and they've got to try to get from one place to the other. Okay, that's for homework, classroom type thing. But in the real world, if you can get something the simpler version, then it's better for computational purposes, as we mentioned earlier. There's less round-off error, things like that. So let's use our skills here, shall we? Which side do you want to start with? Left-hand side, I agree. That's the more complicated side. So we can say left-hand side equals secant squared x minus tangent x cotangent x. It's really kind of annoying. There's no better way to write that. You just have to write it all over again. And then we'll get in the habit of writing our justifications over here that was given to us. Okay, so let's start simplifying it up. What do y'all think? What do you want to do first? Turn it into sines and cosines, okay? We're gonna go one step at a time this one. We've been playing kind of fast and loose. We're gonna do this one thing at a time. So that secant squared, I'm gonna turn that into 1 over, what's secant squared?
Sine.
Cosine.
Oh, yeah.
That's the reciprocal identity. The turning tangent and cotangent, that's the tangent and cotangent identities. We're not gonna do that yet. We're gonna just hold off on that. So I'm just gonna say tangent x, cotangent x, and you'll see why we're breaking this down step by step here in a minute. Reciprocal identities. Then on the next step, we'll break it down. So tangent is sine x over cosine x. Cotangent is not cotangent, it's cosine over sine. And that is what I'll say tangent and cotangent identities. All right, somebody else, what next?
Wouldn't it turn to 1 over cosine squared x minus 1?
That's correct. Cosines cancel, sines cancel. So I have 1 over cosine squared x minus 1. That's just some algebra stuff going on there. All right, any suggestions on what to do now? Okay. So just turn that cosine squared back into the secant squared?
Yeah, and then you can,
Yeah, okay, so maybe don't even do it back into 1 over cosine to begin with. You know what I mean?
Yeah.
If you have a pencil, then you know what, that's great, because you can just erase. If you don't have a pencil, then you can write an extra step. So I'm just gonna actually leave that as secant squared x.
Then we can, take away one entire step.
Because secant squared x minus 1 is tangent squared x.
Right, that's what Josie was saying, yep. So that's tangent squared x by the Pythagorean identity. Now, by the way, if you hadn't noticed that and you had the 1 over cosine and it turned this one into cosine over cosine, or cosine squared, you'd have 1 minus cosine squared over cosine squared. That would be turned into sine squared over cosine squared, which turns into tangent squared. So you could have gotten there, just would have been an extra 3 steps. But since we noticed that secant squared minus 1 is the Pythagorean identity, then we can say, aha, that equals right-hand side. And that's what the problems are going to look like today. All right, let's do a few more. I'm going to change these angles just so you are comfortable with different angles there. That's sine of capital A, so sine A over cosecant A plus cosine A over secant A equals cosecant squared A minus cotangent squared A. How easy is that to see?
it's harder to see on that. Like, I can only see the top part.
Alright, well, while we're making the adjustments, which one do y'all think we should do? Left side or right side?
Left side.
Why left side, Matthew?
Because you can
That's better.
break cosecant down into 1 over sine A, which will make sine squared A, and then you can break cosine A over secant A into, the secant down into 1 over cosine A, so that would make cosine squared A.
Okay. Just so we might be able to do some simplification there. I like it. Sounds good. to me. Also, as a general rule, it is really hard to take something that's not in fractions and turn it into fractions. Okay, so you can put that on your little tips and tricks, you know. Start with the fractions first, because bare minimum you can always, you might be able to do some multiply by the reciprocal of the denominator stuff, or find a common denominator. That's normally a good idea. So, we'll take Matthew's advice and start with the left-hand side. Now, I will say this, Matthew, you might be wrong. Okay? You might be. We might work through this and start getting to a point and we're like, oh, this is not getting us anywhere. All right? 9 times out of 10, that's, sometimes on your homework, that will happen. In which case, you're like, oh, we didn't run into that problem in class. Mr. Goddard just flew through it. I guess because I know the answers. I know how to get them, okay? But you don't know the answers. And so sometimes you're going to probably pick the wrong side. What should you do in that situation? Try the other side. All right, so we're all aware of what needs to be done sometimes in the name of math. All right, so there's the left-hand side, and that's given. Matthew, you suggested turning cosecant and secant into the reciprocals. I like that idea. So we've got sine of A. I'm going to put a big fraction bar. Cosecant, somebody help me out, is 1 over sine. A little smaller fraction bar. Plus
1 over cosine.
Cosine A, big fraction bar. 1 over cosine A. That is the reciprocal identities. Well, I take attendance, see what you can do. See if you can start simplifying those up. All right, so what did y'all do for the next step?
Sine squared A plus cosine squared A, which is algebra.
Okay.
And then that'll
I might break that down just one sub-step there. Writing the numerator times the reciprocal of the denominator. But I hear where we're going with this. That's an algebra step right there. I'm gonna tear that up here. So we've got sine squared A plus cosine squared A,
which is 1.
which is algebra. Okay. All right. Which is 1.
And 1 equals cosecant squared A minus cotangent squared A.
How do you know that?
By the Pythagorean identities.
Does it actually say that? Is it,
You have to mix up the formula.
we're gonna have to mix up the formula. So we're gonna have to do. They're saying, wait a second, Pythagorean identity can do some stuff here. We're gonna have to modify this. We're gonna have to manipulate a little bit. All right. So I need to put my equal signs. So in that case, we need to say right-hand side equals cosecant squared A minus cotangent squared A. That's given to us. And you said we need to do a little bit of a manipulation. So what do you want to substitute, Commission? You know that it equals 1. Does it actually say this equals 1 on the, no, you have to, okay, so let's do a substitution. For instance, what does it say on your formula chart there, Misha?
1 plus cotangent squared
Equals?
equals cosecant.
Okay, so let's substitute in for cosecant squared, 1 plus cotangent squared. And then you've got the minus cotangent squared. You see what I'm saying?
Okay, that makes sense.
So that's how you're gonna have to, you can't just be like, well, if in my head, if I subtract it from both sides on the paper, then it's 1, so therefore it's 1. You have to show your steps. You have to document here. So that's a Pythagorean identity. And then plus cotangent squared A minus cotangent squared A, those cancel. We have a 1, which equals the left-hand side. Well, actually, we'll be extremely proper here. So that equals 1 by algebra. And that equals the left-hand side. So now we've got, wow, I guess it was only a second problem. They met in the middle. How nice was that, right? You know what they say about compromise? A good compromise leaves everyone unhappy.
How would we get from 1 plus cotangent squared A to 1? Can you just explain that?
Sure. This is just 1 plus. They're not multiplied. This is just the parentheses there are just to show you the priority.
Oh, okay.
It's like 1 plus blah minus blah. I normally don't draw the line. I guess I could draw lines through it at that point. Let's cancel.
Okay, yeah, that makes a lot more sense.
They can hear you like really well. Not them. The recording device.
They're watching this.
I'm sorry. What'd you say, Matthew?
They're watching this.
Hopefully you're watching me. Okay. So let's try a couple more problems here. Cosecant. Cosecant of x over cotangent x plus tangent x equals cosine of x. Alright, should not be too difficult to figure out which side to start with.
Cosine.
With the right side.
Start with the right side. There, just
The right
go
side.
there and just randomly add stuff and subtract it so it doesn't cancel out. And yeah, that, I think you know what to do here. We'll start with the left-hand side. Just so happens that on these practice problems I've chosen so far, the left-hand side is the more complicated. So we'll write the given here. Cosecant x over cotangent x plus tangent x. That's given. Alright. Someone other than Matthew and Mission here.
You got to make cosecant be a 1 over sine.
Okay. So we'll just do this one step at a time. So cosecant is 1 over sine. We're going to leave that cotangent and tangent at the bottom as is. So cotangent x plus tangent x. Because we're going to say reciprocal identities. Then turn that cotangent and tangent into sines and cosines. So 1 over sine x divided by cosine over sine plus sine over cosine. That is tangent and cotangent identities. Alright, somebody else, what do you think we should do at this point?
Should we make the denominator, the fractions in there have the same denominator?
Yes, that's a good idea. We want to combine this into one fraction so that then we can do our lovely fraction trick multiply by the reciprocal, the denominator. You might be tempted at this point to do that very thing at this right now and be like, multiply by the reciprocal. You can't do that because this technically is, the denominator is all of that over 1. And so if you were to multiply by the reciprocal, then it'd be like messy. So I'm going to erase that and that and that. So yeah, let's find a common denominator. Looks like over here I've got sine and over here I've got cosine. So my common denominator is going to be
Sine x.
sine x cosine x. So this guy gets multiplied by cosine over cosine, and this one gets multiplied by sine over sine. So numerator is still 1 over sine x. Guys, knock it off. The denominator, cosine times cosine, so that's cosine squared x. Now, I think y'all are probably good enough that you can see, okay, this common denominator, this common denominator, that's what we're doing all together. So I'm just going to put this all over that common denominator. Sine x, cosine x. The first numerator is cosine squared plus the second numerator, which is sine squared. And that is just an algebra technique. Then we can finally do our multiply by the, well, ooh, I just saw something.
You use the sine identities to turn the cosine squared plus the sine squared into 1.
Ooh.
And then you can find the solution.
Yeah, let's do that first. I hate writing all that stuff if I don't have to. So 1 over sine x. I try to draw a really big fraction bar, maybe make it kind of thick, a little bit longer than it really needs to be, just so that it's obvious where my fractions are. Okay, so that's a writing technique there. Sine x, cosine x, cosine x. So replace that sine squared plus cosine squared with a 1 by the Pythagorean theorem. Now we'll do our trick, numerator times the reciprocal of the denominator. So 1 over sine x times, I have to make the sound effects there, sine x cosine x over 1. Oh my gosh, are we finally going to get there? I don't even know where we started from. What are we trying to get to?
Cosine.
Cosine. What do you know? Equals cosine x.
It's cosine x over 1.
Oh no. Well, the algebra will take care of that.
Multiply by 1 over 1. And then
And I think if you had started with the right hand side, would you have ever even thought to multiply and divide by sine x? You know, and then turn that into a reciprocal, you know, and then go, it'd be next to impossible to go the opposite way. So, all right. Trey, do me a favor, go and kill the video there. I'm going to have a couple problems here for y'all to work as a table.